Testing, testing. Good evening. You're muted, Fred.
Thank you. What is that image that's over your left shoulder I'm seeing?
Oh, this is this is my alter ego. I can't get the camera any closer. Let's see. Before Kindle, that would be me roaming through stacks and stacks of books.
Oh, okay. Cute. What are we drinking?
Well, how was everyone?
Well, I missed my clear sky opportunity Tuesday night to shoot Mars, and last night the red planet was very red, and tonight it's just overcast.
Yes, yes.
A friend of mine in Livermore got just an awesome picture, though.
That's good. Was it clear Tuesday night, though?
Well, I guess it was when he took the picture.
Oh, okay.
I remember it being fairly clear on Tuesday night.
Yeah, I think it was. And I was just too lazy to go out.
Oh, don't you hate that?
Yeah.
I worked all day,
Yeah. We've all done that, Fred. Hey, Fred.
Yeah.
I forwarded you a message when I talked to Dr. Nico Smith and to Nick Scott.
Yeah.
Handing it off to you. I just want to make sure there wasn't a fumble.
I actually followed up with.
Okay.
Is Nico a he or a she? It's a she, right?
Dr. Nico Smith, it's Kimberly. It's she.
It's she.
And then the guy. I just want to make sure you got the handoff, basically.
Yeah, so I actually sent her an email the day that you sent that to me. It said, it's nice to meet you. I told her that we'd look forward to having her, whenever her
Right.
schedule is available. So we'll see how that goes.
Yeah. And you got the thing that Nick knows that he's penciled in for May of 21.
Yes.
All
Yes.
Good.
So is this your little man loft you're in, Fred?
My man loft. I have we have a loft at the top of the stairs, and it's kind of tilted ceiling, cathedral type ceiling. And you can see above me there is the moon roof. When I'm too lazy to go outside, I pop that open,
Right,
stick
nice.
binoculars through it. But here, let me just lift it up and you kind of see around kind of the library.
Uh-huh.
I think I just lost you.
No,
Oh,
we're
there
not
we go.
that easy to lose.
There we go.
Mark's having a hard time getting his audio connected though over here.
I thought I saw Mark Gibbons logging in. Oh, I see he's trying to connect.
Oh, Tim is waiting out there.
See if I can add my my buddies here. Nope, wrong background. Oh, I'm on a different computer. Normally I'm on an older computer. I'm on a new one tonight, so it doesn't have my virtual background in it.
Ah. Good evening, Tim.
Good
What's
evening,
that?
gentlemen.
Hey, Tim, how are you?
Good. Hey, Jerry, if I could tell you, I'm at a remote location. I'm up in Lake Tahoe, and I'm a little concerned that in the course of my presentation, my internet connection might fail. If so, why don't you guys just go ahead and go to the next speaker, and I'll try to log back in. But if I'm offline for very long, just please go to the next presenter, and maybe we'll pick up where I left off when I get back on, and we'll
Okay.
decide what to do.
Okay.
Okay. Although that being said, obviously you need to be looking at the waiting room if I'm trying to get back in. I'll be knocking at the door.
That would be
That's
hilarious.
funny. That happens at school with classes quite a bit. I'll start talking or I'll be doing a presentation and all of a sudden someone will break in and say, my friend is in the waiting room.
They're texting each other back and forth.
Yeah, yeah. It's kind of funny. One night I kind of snipped at him a little bit. I says, you can be here on time. We wouldn't have this problem because I was behind a demo bench. I had a bunch of equipment set up that I was demonstrating. But then it dawned on me after I said that the week before, I had let an email distract me. And I was so flustered by this email that I was 10 minutes late logging into a class. So, and it was this same class, so I thought the week before I was 10 minutes late, just opening
You were the
the
tardy
door.
one.
Hey, Tim, do you get a chance to look at any of those old Popular Mechanics magazines?
I've scanned through some of them. Boy, they are a step back in time.
Oh my gosh, I bet.
Yeah.
You
Oh,
think
there you
about
go.
becoming one of those newfangled radio technicians?
If
Yeah, it's so many things we take for granted nowadays that it was new technology back then.
If you ever doubted that Fred might not be from around here, take a look at his escorts. Are they here to take you out of the
Good
building?
company, Fred.
Well, I cannot disclose.
I like it, Fred.
I was going to use this at a corporate meeting. I thought it was a bad idea.
Oh,
I think it's a good idea.
I think IBM would work.
It'd be a career limiting move.
Ah, come on, they gotta have a sense of humor.
Well, they did at one company. They did
I
at one
bet
company I
you're
worked at.
wrong.
When you dialed my extension to one company, it came up Darth Vader. That
Oh, no.
lasted about 4 days.
Oh, Bill and Mark both got their audio in, it looks like. Good evening, gentlemen.
Good evening.
Oh, Mark?
Mark is here in spirit. Oh, there he is.
Hey, Mark.
Hello, guys. Can you?
You were there.
Good evening.
Oh, there
Mark.
he is. Are you in your backyard?
Oh, you're back to muted again.
He's muted. Yeah, he's muted. Unmute, Mark. There he is.
There. Did it work?
Yes.
Yeah, there you
Oh,
go.
good. No, that is just a picture of my scope in the backyard.
Oh,
Right,
there you
right.
Hello, Fred.
go. Hey, Mark, what's up?
Hey. So that's the new. That's the scope that we purchased.
Wow,
the,
that looks amazing.
Yeah. Here, let me get out of the way. Yeah. So that's the Eon 130. Mm-hmm.
Have you had a chance to test it yet?
Yeah, I saw first light a couple of nights ago.
You had
Full
clear
moon.
sky?
Full moon and lots of smoke. Let me see if I can show you an image that I took. Let me pick one here.
It's really interesting how amateur astronomers test their new equipment for first light.
There. So that's my
Wow.
own.
Oh,
That's
very
an
nice.
image taken with that scope in my backyard.
Is that 30? Is that 33?
No, it's I got to look. It's NGC 6946.
Oh, very
It's
good.
just a little one.
Yeah,
called
pretty sweet.
Looks
What's
good.
Oh, thanks.
What's the tech on it, Mark? I mean, how many stacks and so forth?
Oh, it's about a 20-minute exposure. There's not much there, to be perfectly honest.
You're
Yeah,
using the same mount you have.
Here.
I am, and I'm very happy. I'm still getting under 1 arc-second guiding, which surprised me. I didn't think I'd because it's a lot of weight actually for that mount, but it's doing fine. And I took, let's see, I've got another one.
This is the one
This-
you purchased at the estate sale?
It is.
Yeah, wow.
Let's see if I can show that. That is a real obscure object. That's, let me think. It's NGC 7129. That's that little fuzzy guy down in the corner there. And then the little open cluster at the top is 7142.
Wow.
But yeah, so shooting obscure things. I was actually doing it mostly because I'm checking for field curvature, which I do have a little bit of. So I'm going to have to do some experimenting with that.
These were shot in your backyard?
Yes. Mm-hmm.
Wow.
Here. Well, I'm in here. I'll show you. I took one not very good picture of the comet. I never processed it. Let me see if I can get out of the way. There you go.
Wow, that's a good picture.
So that was shot from Tracy, just on a fixed tripod with a telephoto. So that's really really the only, and I took it through a really pretty severe light dome. So it took me a bit of processing to try to get the background dark enough so that you could see the comet.
How much did you have to change the background color temperature?
Probably quite a bit, because it really was more of an orange than anything else.
Yeah.
But I was very happy that I got the ion tail.
You know, when I went out to photograph it, that was my whole mission. If I captured the ion tail, I was happy camper.
Let me get rid of this. That's cool. Did you get it?
Yeah, I did.
Awesome.
There's a picture of it on the Stockton Facebook page, and then there's a couple of them on my Facebook page also. I was very happy on it.
Oh, nice.
Hello, Rebecca.
Hi, Rebecca. Oh, she's muted.
There's
Hey.
Rebecca.
There she is.
Hey, Rebecca.
So
Hi.
Congratulations.
what'd I do?
What you didn't tell us. Congratulations.
After our last message, it dawned on me. I thought, I wonder if she told everyone else that she got married.
Oh,
So
Oh,
the rest of the
yeah.
club is just finding out. Rest of the
No,
board
she
didn't
kept
know.
that a bit of a secret.
Yeah.
sorry. I've been getting used to my new job and things have been somewhat hectic, but
Well, yeah, I saw a couple days ago and they were talking about the Nobel Prize, and yeah, I thought, now that name just seems awful familiar, and then your email tonight says, oh, that's why it's familiar.
yeah.
Awesome.
They woke her up at 2 a.m. to let her
Oh,
know.
yeah, that's right. They're on their time.
But
I'd say it's worth it.
Right. Most people think it's a crank call here or something. Yeah.
yeah, especially since it was on her home phone. It's
Oh,
like
okay.
I know at least here at
It's down here.
I know at least here at my house, like we only get telemarketers on that phone. So
Oh my gosh.
it's like her home phone starts ringing at 2 a.m.
Mm.
She's like, who in the Oh, and then once they tell her, you have 30 minutes to prepare a statement for the press conference.
Wow.
Oh, shit.
We're going to wake you up at 2 a.m. and then give you 30 minutes to figure out what you're going to say.
Nice, nice. Well, if you're smart enough to win the prize, you ought to be able to figure that out, right?
There you go.
Oh,
Eric, you got a uniform now.
wow, yeah.
Yeah, I added me a uniform.
Hey, Paul. Good evening.
Jeez.
So we had to have a contest who's got the most creative background next time around.
Hey, so Rebecca, while we're waiting, why don't you tell us, while we're getting started here, what's your connection with Andrea Getz?
Oh, so Andrea Guess is the principal investigator of the lab group I work for, which is the UCLA Galactic Center group. So her lab group has been studying the galactic center where the black hole is since 1995. And they've been using the Keck Observatory to do that. I am currently a post-bac researcher in that group. So I have gotten I started as an undergrad student researcher in her group. I was doing summer research there. And then when I graduated, because I didn't get into grad school the first time I applied, then I'm taking a gap year and I'm working for the Galactic Center in the meantime.
Nice,
So.
nice.
So yeah.
I would say
Good for you. Good for her. That's great.
That's easily more valuable than a year of first year grad school.
I am learning a whole hell of a lot.
So what are the odds of us using this connection to get her to present to our astronomy club?
Well,
Slim or none?
admittedly, I am not sure. I might be able to talk to one of the other professors in the lab group, but she told me that at last count, she had 7,500 emails from the that came in since Tuesday.
So
Well, what's she
we're
doing
not,
next Thursday at 2 a.m.?
so we're not high on the list.
I know.
Wouldn't that be fantastic though, Fred?
Oh, I would have the record button running all the time. When I saw the news article came out, there was a magazine article like on Discovery or something like that from about, I don't know, the year 2001, 2002, early 2000s. And it talked about the measurements she had made of the stars initially orbiting the black hole. And I thought, wow, that is really fascinating, because to make that measurement, it takes a lot of time. You measure 1 year and you come back a decade later and you get like 4 pixels of movement. So, the amount of work that she did on that is just staggering.
Yeah, and beyond that, they were actually using a new technique that hadn't been used before called speckle holography. But in order to use Keck to get those images of the galactic center, one, you're using both telescopes. They were using both telescopes, and they were also taking, rather than longer exposures that Keck usually does, they were taking, I think they said every like 70 milliseconds or something. But basically, they took all the pictures so that what's the word? Basically, so that the turbulence that you had in the atmosphere, you didn't have multiple distortions layered on top of each other through the exposure. So once they had all the pictures, then they used a technique called shift and add to line up the stars and basically put them together so that they could actually get those images of the stars. And they were doing that for about 10 years before they started using adaptive optics in 2004.
Wow.
Mm.
It was really interesting to read that she got that, because I know she's been kind of pouring her lifeblood into that project over the past 3 decades or something like that.
It was her first proposal.
Well,
Wow.
it worked.
So this was the start of her career from junior faculty. She's been doing this her entire career.
She's getting pretty good at it, huh?
I'd say so.
No, it was very cool. It was very cool indeed.
So Eric,
Well,
I'm
Mark.
curious, are you able to stand up, or are you like trapped inside the uniform?
That'd be awesome if his
You
head
did.
floated up above the uniform.
He's muted. We can't hear him.
No.
I see
yeah.
Nihar's online.
Yeah, I'm trapped in the uniform.
Oh, hello, Nihar.
Hi.
We're
Glad you
curious,
could make it.
have you tried out your new scope?
Yeah. Lots of
Oh,
times.
tell us about it.
It's really cool. I saw Jupiter one night and Saturn. I didn't get to see Mars. I hear that it's really close, but I haven't gotten the chance to see it yet. I'm thinking about doing that.
Excellent. Excellent. And you're getting all familiar with how to take it outside and set it up and focus the eyepiece and culminate it, all those kind of things.
Yeah.
Hello, Doug.
Hey, how's it going, Paul?
Doing good. Good seeing you.
That's good.
There's Eric. Hello, Eric.
Who is that masked man?
That's a clever background. He's got his face there. That's-
You know, I think somebody hit him in the head because you can see stars around it. Boing.
Let's see, there's Jeff and Mike and Bill is here and Tim is here. I haven't seen Dan Dakin log in yet.
And Jerry, you're all set to go with our all 4 slide presentations that we don't have to switch between presenters.
I've got 2 slide presentations.
You've got mine.
I was supposed to have 4.
Dan Balkin and Bill Lytell.
No, I've got Jeff's and yours, Tim.
Jeff and Mike, your video is a little out of focus.
We're out of focus.
Oh, really?
Jerry, you didn't get mine today?
No, well, I haven't checked my email lately. I had labs till 7 o'clock.
From B. Lytle at ACRT Inc.
Oh, there you are.
There I am.
Well, what's going on here, guys?
So Jeff, did you say Dan bailed on us or he's going to be here?
No, he should be here.
Okay.
I'm having some video camera issues here.
Sounds like an optical problem to me.
So Rebecca, you see Nihar Jain on the Zoom meeting with us. Nihar just received Striking Sparks telescope. So why don't you share with him, if you would, just a moment, your experience with Striking Sparks?
Well, this was a while ago now, wasn't it? So Nihar, so I was a Striking Sparks winner back in my 8th grade, which would have been
Careful.
2 years ago, right?
8, 9, 10-ish years ago. Really? Dang. Anyway, so yeah, Janice is still on my. I still have Janice. So that telescope really opened up like everything for me. Like, so I started taking I took my telescope to not just the star. I was volunteering at star parties. I took it to high altitude. I took it on my parents' trip to Yellowstone. I learned that's when I really started learning things about astronomy, because I was trying to do it hands-on. I still remember the first time I found Andromeda. I think Doug was there.
I remember that.
Yeah, I was learning how to star hop. Yeah, I took that telescope and it fueled my interest in astronomy through high school. I took that to college, and now I'm actually working in astronomy. So, yeah, my experience with Striking Sparks, it started what I went for. Would be the short version for me. I am an astrophysicist because of that telescope.
So Nihar, Rebecca is currently working in a research group, and the leader of that group just won the Nobel Prize in Physics.
Oh yeah, I heard about that.
Is that awesome?
Yeah. Aren't they the ones who tried to image a black hole?
That's it.
Yeah. Andrea, Andrea, I guess, was one of the Galactic Center group that she leads. It was one of 2 groups that was really studying the Galactic Center and the black hole and all the stars orbiting it. They got some of the first images of the orbiting stars themselves too. I think the other group's name, the PI, his name is Genzel. They have been rivals for years.
Rebecca, are they competitive rivals or they just don't like each other?
They are competitive rivals, I would say. It started in the 1990s. It started with one would publish a paper, the other one would kind of confirm it because Genzel's group had terrible data and Gez's group had great data. So Genzel would publish something, Gez would essentially confirm it. But later on, it formed into a Genzel's group says one thing in a paper, Gez's group says that's wrong. This is actually what the data says, and it went back and forth. And they've been
Competition
doing that for,
drives the market.
yeah, and they've been doing that for 20 years.
And that's how science works.
It is exactly how science works.
So an email just came in from Dan. He says he needs the link to the Zoom meeting. So
And Bacon.
Dan Bacon. Yeah, so let me see if I can forward it to him as well.
I just Tim with the link to get in.
Okay, thank you, Jeff.
Fred, you need a black suit and sunglasses.
Hang on, I'll get the sunglasses. Hold on.
They're there to escort him. They're not, he's not on their team.
Hey, Jeff?
People that actually really pulled it off good. Yeah.
Jeff, I think actually what he needs is an alien uniform.
Yes.
He needs to paralyze him.
He needs an Edgar suit.
Look at my pen.
If only it could work that way.
Rebecca, congratulations.
There we go.
There you go.
Wait, for the wedding?
Yes, for the wedding and for the black hole.
I didn't win it. I didn't win the prize. That was Andrea.
You rub elbows with her.
I have meetings with her.
Well, I'm proud of you, little girl.
Thank you.
And congratulations on you got your bachelor's degree too, don't you?
Yep, I got that in June. I officially have a degree in astrophysics.
That's
She
pretty
also
awesome.
has
Congratulations.
She also has her MRS degree. Jeff.
Rebecca, are you going to grad school?
So I applied last year and I didn't get in, so I'm taking a gap year working as a researcher, and I'm applying this coming fall again. I'm currently narrowing down my list of schools.
Wonderful. Awesome.
That is cool. Have you tried UHM in Hawaii?
I don't think I'm gonna go for Hawaii just because I still want to be able to visit my family.
Oh yeah. So you're looking for California, or would you go as far as Arizona?
So I started last year. I only applied to schools in California. However, I'm expanding my net of what I'm looking at to continental US, preferably in the West, but depends on where both me and my husband get in. We're trying to go to the same school.
Just leave him behind. He's an anchor.
I'm not going to comment about that comment.
Squiddy, how are you?
Has Dan checked in yet? Doesn't look
Oh.
like it, huh?
There's
So-
Ricky.
Hello,
Jeff.
Christy.
Jeff, do you have any particular order and for the speakers?
I did. It'd probably be nice to have that in front of me, wouldn't it?
And do you want me to field the questions or do you want me to send them right over to you?
I may be busy juggling, so it might be easier if you did that.
Okie dokie.
Give me just a second and I'll come up with the order.
If I recall, Bill and me and Dan and then you, Jeff.
Yeah, okay, I've got it right here. Yeah. So I sent it to Bill and or to Jerry. It was okay. The order is Bill, Tim, Dan, me.
Okay. Sounds good.
And Jerry, are you going to bring these up, or are we going to bring them up? And
I have 3 of them. I'll bring. Whoop. Let me refresh my.
I'm going to keep this up even though he's I'm doing it. Oh, look at that. Look at that. Look at that.
Yeah, it looks like Dan got here
I
too.
told him that I'm also going to be making secondary mirrors.
You are muted, Dan.
Great. We will need a second. Of course they will.
I might
quartz
I
one?
might be making a set.
A quartz, maybe? No?
Everybody's here, Jerry.
Okay.
Well, for an extra, you know.
Yeah, it depends on which way they want.
I'm not sure I have that material.
Yeah. All right.
I think Chris has a whole bunch of that quartz left over. If I'm going to make it worth his while if I do it. Yeah, it's not just me. It's going
They'd
to.
have an awesome system if they have a dual quartz system.
Yeah. Hey, Fred, did you hear about Duggar Pines Observatory?
Yeah. Yeah, it's too bad. When I was with the Telescope Makers Workshop at Chabot, we found Digger Pines, I don't know, 1975 or 76. We were just romping around back there. And then the Livermore group got involved and set up their observatory, and now it's gone. It's too bad.
It's horrible.
So other than the presentation, I did prepare a poll to test doing our election next month. So at whatever point you'd like to do that, I'll bring it up.
Or after Jeff, being that you're the.
Oh, what?
You want to do the poll first or after? To
No,
try?
don't make no never mind to me.
Well, guys, Jeff, who's in charge of the nominating committee, thinks that we should do it after the speakers. You guys okay with that?
That's fine.
Yep.
Hawkins not in yet, right?
Oh, he's here.
Oh, yes.
Dan, you're on mute right now, Dan.
Can you hear me now?
Yeah, there you go. We got you.
Hi, Dan.
Hello.
Hi, Dan.
Howdy.
All right, Mike, light us off.
All right,
7:34.
Okay, folks, welcome to the October session of the Stockton Astronomical Society club meeting. This evening we have 4, I think, wonderful speakers that are going to be giving us information on the universe here. And so I think I'm going to let Fred do the introduction to the first person, and we'll get started.
Okay, very good. Thanks, Mike. Yeah, as Mike said, we have 4 very experienced amateur astronomers tonight. We have Bill from our group who's going to talk about interacting galaxies. Dan is going to be Dan from up in Washington, I believe it is going to be talking about edge-on galaxies. Member at large Tim is going to talk about planetary nebula, and then Jeff, you know, you didn't even say what you're going to talk about on the list here. So
Mars opposition to 2020.
okay, very good. All right, so with that, I'm not going to go into the details of your guys' experience and stuff like that, but I am going to hand it off to Bill. And Bill, take us on to your talk.
all right, Jerry, if we can get the PowerPoint up.
Let's see.
I just want to say to everybody, while the PowerPoint is coming up, you can send your questions in through the chat room, and then we'll let the speakers address them at the end of the presentation. Okay, thanks.
Yeah, and I don't know what I can answer for you. I mean, I am merely a amateur astronomer with just an interest in looking at cool stuff in the sky. I'm an arborist by trade, and I've been one for well over 40 years. And so this is just the goal was to come up with things that we like to look at. And one of the things I really like to look at is interacting galaxies. And so it's Lytle's picks for what objects I really like to look on a night out, or some of the best Nurly bobs you've ever seen. And I don't know if I can, I guess I don't have, oh, there we go. Okay. So what is an early bob belt? And where do I find them? If you were paying attention, when you paid your yearly fees, you would have been granted access to an SAS glossary of terms. If you did not receive that, you need to talk to Gerald Hyatt. Between Killer Night and Could Have Been Better, you'll find knurly bobs. Definition of a knurly bob: knurl, it's a noun. Definition of a knurl: a small protuberance or knob. Then we have bob, which sounded better than knob, so knurly knob just sounds wrong. Next slide, please. So what is a knurly bob? Any object which, through the eyepiece, displays its structure as a series of twists and turning gases. An object that on a rare certain night makes one say, knurly bob. To the right is an example. That's, of course, the veil. So if we can move on. So one of our favorites is M51, the Whirlpool Galaxy in Canis Venatici. Magnitude 8.4, it's 23 million light years away. And it's an interacting galaxy. You could see its little companion down there on the bottom, and it's all diffuse. If you go ahead and click again here. And here it is on a star chart, right there, Ursa Major. It's up in the upper left of Canis Venatici. You could see M51 as the red little oval there below Ursa Major's handle. Go ahead. Another one of my favorite is the Whale and the Pup in Canis Venatici. NGC 4631 and NGC 4627. The Whale and the Pup. 30 million light years away, it's 9.8 magnitude. And the really cool thing about this is that I guess there is so many supernova going off in this thing that it is a very well-studied galaxy in itself, 4631. And on a good night, at the heliport, I think I've seen it pretty close to this. You are definitely seeing, and I don't know, you guys can't see my mouse, can you?
No.
No? Okay. Well, there in the center, you could see sort of the knurly bobs that we were talking about. This is where knurly bobs came from. One night, Jeff and I were out there and at the heliport, and we were looking at these two objects. And Jeff shouted out that he just loves knurly bobs, and that's how it got into the SAS glossary of terms. But you are definitely seeing that fit. If you look to the left of the galaxy there, that little part that falls down there, that's visible. Definitely, all of that other stuff is pretty visible on a good night. Anyways, if we could go ahead and click. Okay, so right by it is NGC 4656. And this was one of my first interacting galaxies here. It's the hockey stick, eh? It's also in Canis Venatici, 11.0 magnitude. And next slide. The great thing about that is that the Whale and the Pup is right down there on the right, and the hockey stick is on the left there. And with the right eyepiece, it's the same field object. So kind of neat to see that. NGC 4038, 4039. It's the antennae or ringtail galaxy. It's in Corvus. It was thought to be 65 million light years away, but then it was adjusted to 45 million light years away. 11.2 magnitude. This is actually colliding galaxy. It's not only interacting, and yeah, it's interacting. They collided it, and it's well into phase 2 of the collision. So the actual cores are beginning to come together at this point. They have smashed together that much and then gone around each other, and now the two cores of the galaxy are actually combining. So that's a phase 2. Go ahead. I haven't seen that one too well yet, but there it is. I drew it in Corvus there to the right, and you could see the little red dot over there. It wasn't on any of the star charts that I have, which is, you know, the Pocket Atlas, and this is actually a star chart from the International Astronomical Union. Go ahead and click. NGC 2207, IC 2163. So this is an example of a phase 1 part of a collision. So they are interacting and they are colliding. They just haven't gotten their cores into it yet. So they're smashing into each other, and there's still a lot of things going on. I think I read somewhere it's another 5 billion years before they really start getting into phase 2. This one's in Canis Major. It's 81 million light years away, 12.2 magnitude. And I put the right ascension and declination there because you're not going to find this one on any of the normal sky charts. You will find it in stellarium and everything like that, of course. But if you click, I did update in Canis Major, and I put a little red dot there. I don't know if anybody can point that out. You can't see my cursor, but there's a little red oval there to the right of the brightest magnitude star there, Cirrus. So if you go ahead and click, NGC 1097 in Fornax. This is a Caldwell 67, 45 million light years around, 10.2 magnitude. And this one was discovered by Herschel in 1790. The distortions are caused by interactions with 1097A back there in the back. And it's just one of those ones where you can, you know, you could see some things going on there. The big old gnarly bobs hanging off of the thing, that big old streak off the nucleus. And if you click, there it is in Fornax. So it's kind of low in the sky, especially at Peddler, the way that we're positioned. If we're up on the top part where the astrophotography goes on, it's kind of low in the sky. But if you're down there in the bottom, where we usually have the group supper on SAS night on the hill, you'd be able to knock this off pretty easy. So that's, I think that's my last object. Yeah, that is my last object.
All right, very good. Any questions of Bill? I don't see any on the chat box.
I see. Okay.
Okay. All right, Bill, thank you very much. If you have questions, make sure you forward them to the chat box. And you know, as we go through this, we can go back to the speakers and ask further questions. Without further ado, Mr. Tim Clark, our member at large, you are up, sir.
Thank you, Fred. And Jerry's going to put the slide deck up here. And we'll get started.
Just while Jerry's putting that up, I want to tell everybody that Doug and Tim are Apollo aficionados. Anything to do with the Apollo program, you go talk to these guys. They've got it like committed to memory from Apollo 1 all the way to splashdown on 17.
Let me rebut that. Tim knows it all. I don't.
We can mute you, Doug.
I know.
Okay. So this slide is just a reminder that astronomy may not be as safe a pastime as you all think it is. Next slide, please, Jerry. Okay. So I'm pleased tonight to share this presentation with you on observing planetary nebula. I prepared this because I have found that I am very interested in planetary nebula only after learning about them, observing them, studying them, endless hours of website searches. And so, Jerry, if you'd go to the next one, please. You'll see here an array of just a sample of planetary nebula. Now, admittedly, they're not going to look like this through your telescopes. We're going to talk more about that. But I have found I really enjoy these planetary nebula because they're fairly relatively comprehensible in terms of the scale and the physics that's going on. They're comprehensible because basically they're illuminated gas of certain types of dying stars that are roughly the size of our own solar system and the type of stars that our same sun is. And that they're on a scale that light can pass from one end of the nebula to the other in a matter of just a few hours. We're not talking light years of, these galactic scales. So to me, that's more comprehensible. Even one of our current spacecraft could cross one of these nebulas in a matter of years, just to give you an idea of the size of them. And because we're observing these objects through a telescope or photos, what you're doing is you're witnessing the end of the life of stars and their solar systems. Much in the same way our own sun would expire after creating its own planetary nebula in a few billion years, when it's our star's time to end its life as it boils off its outer layers. Mostly these planetary nebula are just so beautiful with these amazing colors and with the large variety of shapes to observe and study. I've just really enjoyed looking at them. And there's the previous slide showed you just a sample, but it's estimated that there's about 3,000 planetary nebula existing in our galaxy. And then I believe that every galaxy is going to have the perhaps into the hundreds of thousands. They are visible through backyard telescopes and with small telescopes, and you got to be really determined to find them and to search them out. So next slide then, please, Jerry. So y'all remember your basic astronomy, how stars are born. They're birthed out of mixtures of gas and dust that coalesce, and gravity and nuclear fusion take place. And out of these nebula, stars are born. Stellar nebula, nurseries, such as the Pillars of Creation, there on the left, magnificent photo by the Hubble Space Telescope. And then also one that's very familiar to us, M42, the Orion Nebula. This happens to be a photograph that I took at the heliport in June of 2019 with some very modest astrophotography gear. And as I go through these slides, I will show you and tell you that these little tables I've created here are basically the name or the catalog number of the photograph or the object, the size in this case arc minutes, the distance and the constellation that they reside in, the apparent magnitude, and then the last line there is kind of a credit to the photographer or whoever developed created the image. I will have to share credit for the image of the Orion Nebula with my friend from the club, Jason Keys, helped me do the post-processing on this image of Orion Nebula. Okay, Jerry, next slide, please. So I found this graphic representation of the life cycle of a star. And so we're going to look at the top row primarily and talk about, because that's the type of star that evolves into a planetary nebula that we're talking about tonight. The bottom row is a type of star that is more massive than our sun, much more massive, and they'll evolve into supernova and then into black hole or neutron stars. We're not talking about those, but look at the upper row there. So as we just spoke about in the previous slide, the stellar nebula is where the stars are birthed or begin. They turn into an average star, very similar to our own. And then as they go through their life cycle, they turn into a red giant. And then as that red giant burns hydrogen in its core, and it starts to diminish, and the gravity starts compressing the core, and that causes a rise in temperature. And then this high core temperature makes the star's outer layers expand and to create that much larger red giant star. And this end phase of a star, and you all know and you recognize the red giant, the one that sticks out in my mind is Betelgeuse in Orion. But this end phase causes this dramatic rise in luminosity of the star, where the released energy is distributed over a large surface area, and which in fact causes the average surface temperature to lower. And then during this phase, the star can lose as much as 50 to 70% of its total mass through its solar wind, expelling the gases out into the interstellar space. This venting of the atmosphere continues, and when the outer surface of the exposed core reaches temperatures, very high temperatures like 30,000 Kelvin, these are enough to emit ultraviolet radiation. And then that ultraviolet ionizes that ejected atmosphere, that gas that it has ejected out into the space around it is then illuminated by that central star. And then we have the planetary nebula. Well, planetary nebula exists for somewhere on the scale of tens of thousands of years. So they're not all that long lived from what I've read. They continue to expand, and that gas distributes back out, and it's recycled back in to create new stars again in the stellar nurseries. And then that central star would probably become a white dwarf, continuing to cool, and eventually that's the end of its life as a white dwarf. Or somebody help me out, but maybe there's even another stage after white dwarf. Is there a black dwarf, or what happens to a white dwarf after it's lost all of its fuel?
Brown dwarf.
Next slide, please, Jerry. What'd you say?
Brown dwarf.
A brown dwarf. There you go.
Our sun will be headed to be a brown dwarf.
Okay, so the discovery of planetary nebula was first made by the famous Charles Messier as he compiled his famous catalog. He first discovered the planetary nebula, the Dumbbell Nebula, M27, in 1764. So you all recall the story of Charles Messier was compiling a catalog of everything that wasn't a comet, because he was trying to find a comet. And so he created this terrific catalog now for us of all these bright objects, these deep sky objects, including planetary nebula. And so he first identified them and discovered them. And then it was not too much later that William Herschel, he had just discovered Uranus, and he saw the Dumbbell Nebula that Messier had discovered. And observing it, he thought it looked like another gas giant, like his discovered Uranus planet. So he named it a planetary nebula. Well, centuries have gone by and we're still calling these things incorrectly planetary nebula. So when you see the name planetary nebula, understand that this is just a big misnomer, that we can go for centuries calling things the wrong thing, like, you know, jumbo shrimp or morning sickness or federal assistance, things that they sound right, but they're not right. That's what a planetary nebula is. Don't think of it as anything to do with a planet. Think of it, everything is to do with nebula and gases. Okay, next slide then, please, Jerry. Okay, so through your small telescope, through this is what you may see in the constellation Draco, where NGC 6542, the Cat's Eye Nebula. There in the center, at the top of the slide, you see a little faint fuzzy. Through a small telescope, that's about all you're going to see. So you really need to pump up that magnification or revert to some kind of imaging and gathering light over time, multiple exposures, in order to get what you see in the next slide. This is a Hubble image. Now, naturally, Hubble's got these fantastic images, but because it's imaging in ultraviolet, visible, and infrared. But you do see here the Cat's Eye Nebula is this spectacular, colorful object, which you can see the central star there. Think of that as that dying star that's emitting this ionized radiation. And then the gas that it's around it is what used to be part of the star. It's expelled off into space around it. And now that gas is being fluoresced or illuminated by that ultraviolet radiation coming from the dying star. Okay, Jerry, next one. I think you all have seen through your telescopes the Dumbbell Nebula, M27. And there's three images of the Dumbbell Nebula here. It's a rather easy object to find in a dark sky site near the Summer Triangle. And it's the brightest planetary nebula visible from Earth. And as I mentioned before, that it's the first to be discovered by Messier in 1764. These three images show you the degree of detail that can come out of improving photography or improving image, where the upper left-hand photo is my photograph that I took at the heliport last year. The lower right-hand photograph is an image that Mark Gibbons shot at Peddler Hill last August. And thank you, Mark, for letting me use the slide, even though I didn't get your permission. But it's a stack of 1 hour exposures. And so you can see that much more definition and color coming out in it. And then our old friend Hubble naturally does us all gives us a much better image, more vivid colors, more details. You start to see the different layers and the depth and the resolution and the Nerley bobs coming out in that image of the Dumbbell Nebula. Okay, next slide is the Helix Nebula in Aquarius. Absolutely fantastic image of the Helix Nebula. It's the closest planetary nebula to Earth at 655 light years away. This image is a combined wavelength image from NASA's Spitzer and Galix space telescopes. The ultraviolet from Galix there shows as the blue, and then the Spitzer shows the detailed infrared signature of the gas in the yellow. So there again, you can see that expanding outer shell just drifting out to being blown away out into space around the central star. Okay, next slide, please, Jerry. This is NGC 6826, also known as the planetary nebula in the constellation Cygnus, known as the blinking planetary nebula. When viewed through small telescopes, the brightness of this central star overwhelms the eye when viewed directly, and so it really obscures the surrounding nebula. However, it can be viewed well with your peripheral vision, your averted vision, which causes it to blink in and out of view as you observe it. A distinctive feature of this nebula are these two bright patches on either side known as flyers, F-L-I-E-R-S, or fast low ionization emission regions. They appear to be relatively young, moving outwards at supersonic speeds. The X-ray emissions from the is colored purple, and then the optical emissions from the Hubble Space Telescope are colored red, green, and blue in this image. Next then, Jerry, please, is the next slide shows the Ring Nebula, much in what you would probably see in a telescope, maybe 10 inches in diameter or smaller aperture. Fairly easy to find deep sky object in the summer triangle in small telescopes with this just distinctive ring or donut shape, magnitude 8.8. But then, next slide, please. The Hubble telescope shows this magnificent, vivid image of this combined image of ultraviolet, visible, and near infrared light. You can clearly see that central star illuminating and fluorescing the gases. The red that you see on the outer fringes of the shell there is hydrogen and ionized nitrogen. The blue is ionized helium, and the green, you see some green or aquamarine color there, is doubly ionized oxygen. So the physics of all that is a little bit beyond me, well beyond me. So we'll bring Jerry into or Rebecca into the Q&A session here if you have questions about the physics of what's going on with these gases and the way they're being ionized. But the result is just these magnificent images that are so enjoyable to observe. And so next slide, Jerry. I did want to mention the way that I observe at a sky party is often with my telescope set up, a table, in my iPad, my chair. And so I'll find through my planetarium software that I've got on my iPad, and I use Sky Safari, but I know many others have different preferences for planetarium software and applications. But and I know this is kind of this is not intended for you to read. It's too small, but I wanted to show you that what I really enjoy doing is taking this planetarium software, looking at an object through the eyepiece, focusing, using inverted vision through the eyepiece, and then going to my planetarium app and reading about it, looking at photographs, studying the information there, learning the history, all the facts and figures. It just makes a real enjoyable experience to really enjoy that object for maybe 30, 40, an hour long or so, tracking that across the sky, learning and reading about it. Really kind of a enjoyable way that I like to observe. Maybe even get up and walk over and ask somebody to come look at the eyepiece with you. Maybe throw in a couple of different filters while you're observing, and really kind of experiment around with how you see that image, what the difference is between the image that you see in your eyepiece and what you see in your app. So again, that's really one of the ways I enjoy observing at sky parties. Okay, the next slide, I wanted to close with this absolutely spectacular image of the spiral planetary nebula that unfortunately is not going to be visible to us here in the Northern Hemisphere. This is in the constellation Musca, and the Musca constellation is located in the southern sky, just to the south of the Southern Cross. And its name in Latin means the fly for the constellation. But for many years, this planetary nebula was thought to be just a bright emission nebula because they couldn't really make out a central star, and it didn't have the shape of a traditional planetary nebula. This spiral shape was really confounding them. And it was assumed that there was it's a binary star system, and the binary stars are interacting in such a way that it's disrupting this even flow of gas out from them as that central star is dying. The Hubble Space Telescope imaging showed that S-shaped structure is indeed two ionization regions, one moving northeast and the other moving towards the southwest of the nebula, so opposite directions. And that could be the result of that central star pulsing or continuing to expand gas out into the region around it. And then later observations with the South African Large Telescope finally found that there is in fact a white dwarf companion to a binary in a 4-day orbit around the central star of this planetary nebula. So again, the vivid colors and the tendrils and the detail that you see in these planetary nebulae and the astro images that we are able to get from these space telescopes and land-based telescopes are just really enjoyable and interesting to observe. So, well, that concludes my presentation. I so want to thank you all for this opportunity.
Thanks, Tim. Any questions? You can go ahead and send them in through the chat. That would apply for both Bill and Tim at this point. If there's none, we'll go ahead and move on and take a moment to introduce Dan Bacon, who's calling in all the way from Washington, I believe, is going to talk about Edge on Galaxies. Dan, go ahead.
Okay, I guess I need to have the host enable my screen sharing. Okay, there we go. Okay, can you see my presentation now?
Yes.
Yes.
All right. I'm going to be talking about Edge on Galaxies. And so we'll just quickly mention that this is my telescope. It's 41 inch. And Jeff actually helped finish figuring it with me. And this is up at Table Mountain Star Party in Washington State. That's near the Canadian border. And this is just a close-up of the business end, I guess. Showing you a sense of the scale. And this is how you wash a mirror of that size. Is everyone seeing that?
Yes.
Am I going?
Yeah.
asked to talk to amateur groups, you never know how everyone's level is, how much astronomy they might know or about observing. So I'm throwing in just a little bit of material here about deep sky observing. And so, of course, in deep sky observing, a dark sky is very essential, because whatever object you're looking at is typically very dim. And so the background skies allow you to have contrast between the object and the sky. And if that background sky isn't very dark, it's not going to be very successful. The background, well, I just said that, sorry. So deep sky objects, of course, are low surface brightness typically. Not always. The Ring Nebula, for example, is actually quite high. And you want to be as comfortable as possible at the eyepiece. So you need to make sure that you're ready to observe and you're not having to do any weird motions to get to the eyepiece, so that you can actually stare in the eyepiece there for, I'd say, even if you're just taking a quick look, stay there for about 20 seconds or more, so that you have a chance to see as much as you can there. And you want to have some sugar in your bloodstream, because your retinas require a lot of energy to function well. And so your retinas are like muscles, and so you want to be, your whole body should be well rested, even though you don't think of your eyes as needing rest. And you also shouldn't be out, if you can, in full daylight brightness for even a day before you go out and observe, if you want the absolute most out of your observing experience. And of course, the more you do deep sky observing, the much you'll get more out of every time you go out. And so if you can practice this skill more often, you're going to get more and more out of it and see more in the eyepiece. And you want to try high power eyepieces, and sometimes that might seem paradoxical. And you want to try to use your averted vision, if you know about that. It's very simple. If you want to look at an object and you're using your right eye to look into the eyepiece, you want to look to the right of the object about 40 degrees off, and that will place the highest concentration of those low light detectors in your retina, called the rod cells. But they're not very high density anywhere in your retina, and so your night vision is very low resolution. And even though these objects are dim, you might think that you'll want to use low power to make those objects brighter against the background sky. But actually, since your night vision is so low a resolution, many times at least, higher power will help your retina recognize that there's actually something there and not just noise that your eye actually does a good job at rejecting. And you'll usually be able to see a lot more detail in it. For example, if you're in a dark situation and you look at a newspaper, almost certainly you won't be able to read the text in the newspaper. You might be able to possibly read, say, the headline, but that text is just too low a resolution for your eyes to be able to read. It's the same kind of thing in the eyepiece. So you might want to keep that in mind. And I noticed that this is quite a bit a result of the seeing, or how stable the air is that you're looking through. And so when you go too high in magnification, things just turn to mush if the seeing isn't very good. So I recommend trying to go out more often when the seeing is actually predicted to be good, especially if you're limited in how often you can get out. And so the first object I wanted to talk about in Edge on Galaxies is actually the Milky Way itself, because effectively the Milky Way in the night sky is like an edge on galaxy, even though it's quite different in scale than what we're used to thinking about. But in reality, that's very much like that. So you can get the sense of it in this photo, that you can see a dust lane there, and you can see the upper and lower parts of the Milky Way. Now we also have the nearby stars that are kind of crowding the image, but nonetheless. So we're inside of a spiral galaxy, which are edge on galaxies, just like what we're trying to look at out in intergalactic space. And you can again see that dust lane there, which, if you can see my cursor here, it goes across here, and it's not super clear like many of the times we see it out in the other galaxies, but it's really not mostly dust, although that's certainly part of it, but it's mostly cold gas clouds that cause these dark regions across galaxies. And so again, they're just cold gas, and they absorb the light, the starlight, from behind them. So that's why they're darker regions. It's not an absence of stars there at all. And so, of course, the Milky Way stretches from horizon to horizon, so it's kind of hard to give you a size on that. But that's what I'll do here on these other ones. And I'll start with my very favorite object as far as edge on galaxies is NGC 4565. And this is the edge on, well, I'll get to that. It's also known as the Needle Galaxy. I don't know why I've never gotten used to that name, but a lot of people do refer to it that way. It's in Coma Berenice, which is the hair of Berenice, is what it means. It's about 40 million light years away. So that's quite a distance. And in the eyepiece is about 16 arc minutes across, to give you a sense of scale there. So that's about 1/4 of a degree. And probably my second favorite, it's almost a twin in some ways, is NGC 891. Now, one of the big differences here is you can tell that the background of the Milky Way stars is a lot more dense in this area. This is in Andromeda. Of course, we know of another galaxy in Andromeda as well. And this one is sometimes known as the Silver Sliver Galaxy. So don't try to say that too fast, it might come out wrong. And this is about 40 million light years away. It's similar. And it's about 13 arc minutes across, just slightly smaller in the eyepiece. And so this one, of course, you can really see that dark lane. Now, in a telescope, we don't see the detail nearly as good as this image. This, I believe, is from the Hubble telescope. But nonetheless, both of these are examples of edge-ons with very prominent dust lanes, which again, that's a little bit erroneous, but we still typically call them dust lanes. And so this is the Andromeda Galaxy, the other big galaxy in the constellation Andromeda. And of course, it's also known as M31 on Messier's famous list. It's about 2.5 million light years away, which places it as the closest spiral galaxy to us. And it's not technically edge on, but it's close. And we can, in a telescope, even see some of these, again, dust lanes going around it there, but it's not edge on technically. But this one is visible to the naked eye in a dark sky. It's actually magnitude 3 or so. And it's about 3 degrees across, which is much bigger than any of the other galaxies we see in the sky, other than our Milky Way and the Magellanic Clouds, of course. So here's another one of my favorites I love to look at, and this one's called NGC 5907. It's also got a nickname, actually 2 of them, the Knife Edge or the Splinter Galaxy. And I just call it 5907, just used to that. And this one's nearly circumpolar, so it can be seen quite often during the year. And it's about 13 arc minutes across again, very similar to 891. It's about 11th magnitude, so it's not too dim, a little dimmer than most of the Messiers. This one's a little farther at 53 million light years away. Now this one, I think it's a relatively recent discovery. You can see these streams of gas around the galaxy. Of course, this is actually stars and gas. And it looks like it's undergone some kind of collision with a small galaxy. And that might also explain why it's a little warped. You can see it's not exactly straight here, especially right in here. You can see it definitely bends on the end there. Probably a result of a galactic collision with a small galaxy. Okay, and here's a Messier object, the Sombrero Galaxy. This one's kind of nice because it really has a large halo. And so it's not exactly edge on, but we are just able to see that very bright core there. And then we have a nice large halo of stars. The Milky Way has a halo like this, but not quite as pronounced. And this one's very pronounced in its halo. And so that one's in Virgo, the Virgo cluster. It's about 29 million light years away. And it's about 8th magnitude, so it's pretty bright, easy to catch. And it's only about 9 arc minutes across, though. And I was reading a little bit about this. This is only about 30% the diameter of our galaxy. It's actually quite small compared to our home galaxy. So I thought I'd just show this variety of other shots, although we already covered 5907 there. But all of these galaxies are really interesting to look at in an eyepiece. And spiral galaxies often, when they're face on, kind of like the Whirlpool galaxy, they can actually, the spiral arms part can really fade into the background and be very difficult for telescopes if they're not big enough to catch enough light of those outer spiral arms. But the edge ones, they're usually high enough surface brightness over the entire galaxy. And that's why they're so interesting to look at and can be really popular. And then when you can see a spiral, or I mean a dust lane across the middle of it, that makes them even more interesting. Or of course, when you get these gnarly bobs and these things, really quite interesting. And I know you already got some information on the Whale Galaxy. It's also one of my favorite galaxies. And this one's kind of an odd galaxy. It's got a lot of starbirth going on in there. You can see these red areas, those are starbirth areas. And of course, it also has a lot of supernovas going off at the same time. So this has got lots of starbirth and then also lots of supernova at the same time going on. So this is a very active galaxy. And there's some disagreement over whether this is truly an edge-on spiral galaxy or something else. One of the reasons, of course, is that at first it looks like an edge-on galaxy, but really you can see that it's very asymmetrical for an edge-on galaxy. So the left side is much wider than the right side, for example, there. So again, lots of gnarly detail there to be seen in a bigger telescope. And as you already know, the hockey stick galaxy is also nearby. For my telescope, I don't have an eyepiece that will show me both in the same field of view, so that's pretty nice for those that have that ability. This is about 10th magnitude, so it's pretty bright. So even though it's not a Messier object, it could have easily have been one. And it's only about 30 million light years away, so it's pretty nearby relative to some of the others we've been looking at. And it's about 1/4 of a degree across as well. So that gives you an idea about that one. And so that is the end of my presentation.
All right. Thanks, Dan. No questions came in on the chat related to the presentations, but if you have any questions for Bill, Tim, or Dan, please go ahead and post them on the chat. And of course, last but not least is our telescope maker and experienced presenter. And Jeff is going to talk about, I believe, the Mars opposition. Go ahead, Jeff.
Jerry, do you mind if I run my own PowerPoint?
Oh, you're welcome to.
Okay, so you know the next $64,000 question. I'll share screen. Boom. Okay, I think I got my game on.
Okay.
So I'm assuming that at this point you can see my Mars opposition screen?
Yes.
With my mouse?
Yes.
All right, howdy, ladies and gentlemen. I'm Baldwin, and this year we have a Mars opposition that is pretty awesome, and we've already been up to look at it. I was going to say this is one thing this year that doesn't stink, but the smoke is wrecking it for us, so it stinks too. But maybe we'll have a rainstorm and it'll clear it out here. All righty. Mars and Earth are orbiting the sun in this little picture here. And when Earth and Mars are lined up with the sun, with the Earth between it, we have opposition because Mars is in the opposition, in the opposite direction as the sun. Now, Earth's orbit is elliptical, but very close to being a circle. Mars's orbit is much more elliptical, more eccentric. And so you can see the oppositions on this side are closer and oppositions on that side are further. So when we have an opposition over here, Mars is, 35, 40 million miles from the Earth. It's still not all that big. But when we have oppositions on this side, Mars is very close, only, 20-something million miles away. And so Mars looks a lot bigger. But there's another component that would be how high in the sky is going to look. So Mars takes 2 6 years to go around the sun. So here's Earth, and in 2 years it went once, twice. That period of time, Mars went once, a little more than once, and about to here. So when Earth went around twice, Mars is still ahead of it. So Earth has to go a little bit further for it to catch up with Mars. And so it's about 2 6 years, somewhere in that vicinity. Now, when Mars is on the perihelion side, it's going faster. When it's on the aphelion side, it's going slower. So when the opposition is on this side, Mars is going faster. Earth has to go a little bit further to catch up to it. So the time between oppositions is a little bit longer here. So here we go. If you look at the synodic period of Mars, that's how long it takes for Earth to lap Mars. So Earth goes around the sun in about 365 days. That's about 0.986 degrees per day. And Mars takes 687 days to orbit the sun. So 360 divided by 687 is about a half a degree per day. So Earth is going around the sun faster than Mars in angular measure. And so that's about 0.46 degrees per day faster. So in 2 days, that's 0.9 degrees. In 3 days, that's 1.4, whatever. So after a while, Earth will finally catch up to Mars. How long does it take? Well, if I take 360 degrees and divide by 0.462, it takes Mars and Earth 779 days to line up with each other. Now, on the big side of Mars's orbit, it's going slower. So Earth has no problem catching up to it. So back in 2012 to 2014, it only took 766 days to go from one opposition to the other. But on this opposition from 2018 to the one that we're experiencing now in 2020, it took longer because Mars went around the sun a little bit further and Earth had to catch up to it. So it's taken us 809 days to do it. So the actual number of days between oppositions is not always 779. It varies. But if you notice that from 2016 to 2018 is very close. Actually, from 2014 to 2016 is very close to 779 days. Okay, so Mars right now, actually a couple days from now. What is today, the 8th? Okay, so about 4 days from now, Mars will be in opposition and it'll be 22 seconds wide in the sky. It was a hair bigger a couple days ago because the date of opposition does not land on the date that it's closest there because of the longitude of perihelions. We have slightly differences. So Mars is 22 degrees or 22 seconds, arc seconds in diameter in the sky, which is huge, but it's not as big as it was 2 years ago. However, 2 years ago, for viewers in Stockton, California, Mars was 26 degrees high. This time around, it's 60 degrees high. So this altitude to look at Mars for Northern Hemisphere viewers means we're looking through less turbulent air and Mars looks clearer. So the difference in clarity between 22 and 24 is pretty minute. But the difference in clarity between 60 degrees high and 26 degrees high is huge. So for Northern Hemisphere viewers, Mars is about the same size as it would be if it were 2 years ago, but it's higher in the sky, so it looks better. And I got to tell you, when we looked at it a little while ago, it was the best I've ever seen it. Now that I've looked at Mars enough to really judge that. So when is the best date for perihelion? For opposition, that would be the date that puts Earth and Mars, doggone it. Earth and Mars lined up so that the opposition occurs right at perihelion, which means Earth would have to be right here's perihelion. Earth would have to be right there on its orbit at the date of perihelion. When does that happen? It happens in September 19th of 2035. The longitude of Mars's perihelion is 335.7. That's the heliocentric longitude. And that is the longitude of Earth every year on August 28th, plus or minus a day because of the whole irrationality between days and year. So if we can get a opposition on August 28th, it will be as big in the sky as it will look. Well, we got a really big one on September 15th of 2035. That's not August 28th, but it's pretty close. And Mars will be 25 arc seconds in the sky, which is pretty good, but it's only going to be 44 degrees in the sky And on top of that, that's 15 years from now, and I'm not even sure I'm going to be alive in 15 years, so I better take advantage of this one. Okay, so when you look at Mars at opposition, at the current opposition, the most striking feature is the pole here. We're looking at the small pole. Mars has a small polar cap and a large polar cap. And when the smaller one is pointing towards us, we see it, but the top one is over the horizon. If we were to have oppositions in April, we'd be looking at this pole with a large cap, and this one would be hidden. So there's a lot of other things to look at, and it all depends on how good of a liar you are. For example, Valley Marineris, Olympus Mons, just right about there. Here are those 3 volcanoes. A lot of people are doing digital photography and stacking the images and clearing it up and actually pulling these details out, like this shot right here. So these details are technically viewable. I'm not an expert on Mars, so I'm not going to make any claim to anything whatsoever. The one thing I want to look for are those doggone moons. I've clobbered all the moons in the solar system I ought to be able to clobber, except for Phobos and Deimos. And so that's my goal right now, is to get the smoke to clear so we can go up and catch Phobos and Deimos. So there are 20 observable moons in our solar system, 21 if you count Amalthea, but that's a hard one. It's inside Eos orbit of Jupiter. But 19 and 20 would be Phobos and Deimos. They're observable, but Mars is so bright that the glare alone wrecks it. When we tried a few weeks back, we were able to put I put a eyepiece with a razor in it and moved the telescope so that Mars was behind the razor, getting rid of that glare. But I still couldn't see Phobos and Deimos because the smoke in the air, even at 7,000 feet, was just too illuminating, and we could not see Phobos and Deimos. But we're not done trying. So the idea is to put a razor in your eyepiece and put it so Mars is behind it and look for Phobos and Deimos. The other thing is, if you go to this website right here, space.gapl.nasa.gov, you can click around and find out what position Phobos and Deimos will be in at any day and time. And so you can schedule your observation of the planet so that Phobos and Deimos are far enough from the body of Mars that it will make it easier to observe. I can't talk with experience because I haven't made this observation yet, but I am going to. All righty, I think I am wrapped up with my presentation. And so if I work this out right, I can stop share and
Jeff, thank you.
Yeah.
Right, very, very good, Jeff. Thanks so much. Take a moment to thank all 4 of our speakers and say what a great presentation is for you guys to put this together and share with everybody. Any comments or questions, go ahead and send them in on the chat. At this point, Mike, I'm going to go ahead and turn it back over to you.
Okay, I think what we want to do now is just do a trial run for the elections. I think so far we haven't had anybody volunteer besides the existing board members. So I'm hoping if anybody is interested that they'll go ahead and put their name in. Remains to be seen. So Jerry, you want to go ahead and get on that as far as the trial run? And I don't know, can they hear us? Are we on mute?
Are you able to hear us?
If we're not, I feel like it.
Fred, can you hear us?
We can
Yes,
hear
I
you.
can. I can hear you.
So I've got the poll up. I put the first one is choose 1. The second one is choose 2. I figure for members at large, we were going to choose 2, right?
Yep. Do we just send it in once we click?
Yeah. Nobody likes my favorite star.
What's your favorite star?
Sharnar Kaptishishutu.
Gesundheit.
What is that?
It's one of the starts, one of the points on Taurus's horns.
Oh,
Oh,
we all do that.
yeah, exactly.
Like all the interesting names, it's Arabic.
While you're doing that, Jerry, can I answer Eric's question?
You can. I think Nihar was asking about a star party too.
Okay.
Oh yeah. Eric's question's about the. Yeah, go right ahead.
Okay, I'll hit Eric's question first. His question is, do you need a special eyepiece to put the razor blade in? Will any work? No. The one that really won't work are these new Nagler and Ethos types, because a Nagler or Ethos has two components to it. It has a Barlow first part, which is 2 or 3 lenses, and then the eyepiece second part, which is 4, 5, 6 lenses. And the focus manifold, the eye relief is inside there, so you can't get the razor to the focus part of the eyepiece. So the first one I tried a 8 or 9 millimeter, who knows what kind, maybe an orthoscopic or something. And the tube inside, it was small, so I had to break a razor and stick it down inside the tube, and it was just awful. So I got a long focal length Plazl, a 32 millimeter Plazl, which has the entrance pupil ring accessible. I put the razor across that, so the razor's in focus. And then I use a 5 power Barlow with it, makes it a 6 millimeter eyepiece. So that's what I did, and I've had luck using it. I just haven't had luck finding Phobos and Deimos with it. The other question was, Nihar's asking about star parties. So officially there are no star parties, but Saturday night is the night that many of us would either go to Highway 4, or if we want to give higher above the smoke, go to Peddler Hill. So the best way to find out who is going where and when is to be on the Yahoo group, because that's where we post our intentions, where we post our disasters, like, hey guys, don't come here, there's a 19 campers or something like that. So if you haven't gotten onto the Yahoo group yet, I highly recommend that you get on the Yahoo group, and we will state our intentions at the appropriate times.
Very good. So first of all, is there anyone who can't see the poll?
We cannot.
You
I
still
cannot.
can't. Yeah, I've got
I do.
15 of 20 voted.
Oh, sorry, I didn't submit.
We do not see a poll.
I did not see the poll.
Okay, so this might not work for us.
First question is, did everybody upgrade to the latest Zoom?
Now that I didn't do, because I didn't
That's
see where I
probably-
was supposed to do that.
Yeah. If you
My
didn't
upgrade-
update, you probably can't see the poll.
My upgrade failed, so how would I go about doing that again? You know, if people can't get the upgrade that lets them vote, perhaps they could message Jerry with a vote.
Oh yeah, that would work.
That'll work.
How many votes did you collect, Jerry? How many ballots?
15 of 20.
Oh. So add Jeff and add Doug, that's 17.
And yeah, for some reason, it's on my screen anyway. Maybe it's because I put it up. I thought I could vote at first, but now I can't vote myself.
And while you guys are working on that, let me call your attention to, there's one more question in the chat.
Which one are you looking at, Tim?
The last one from Nihar.
Can anyone run in the elections, and does it have to fit the requirements? I think anybody can participate in the elections. You can nominate yourself if you want. I don't think there's anything in the Constitution that prevents that.
You have to be a member in good standing, though. You have to pay your dues.
Yeah, you have to be a paid up member.
Yeah.
But Nihar is paid up because
Yeah,
he
yeah.
is a member.
Okay. Actually had one more vote come in. So far, Betelgeuse is the favorite star over Sol, Shurnar Kaptisha and Dolly Parton.
I like Zubin El Janubi.
There you go. That's a good one. What should be done with Pluto? The top two vote getters were leave it be or reinstate it into the League of Planets. And then following way to the back is blasted to smithereens next time we pass by, and turn it into a penal colony back down there too. So. Okay, so I'll go ahead and end the polling. We ended up with 16 of 19 votes, which means somebody left during all this. Hard to believe.
That's what I'm saying. Gotta watch these votes.
It looks like we're down one count from when we started.
Yes. Oh, there is someone in the waiting room.
Many people are having trouble with the Zoom poll. My better half recommended we use the Google poll. Like a Google, what is it? Just a Google?
Google Forms is
Google Forms.
the platform.
Ah.
If you're okay with using Google products.
For those of you who don't know, Rebecca just got married.
Congratulations, Joseph.
Well, thank you.
So
what's the verdict, Jerry? Is this going to be a viable way of holding an election?
Well, there's people that still aren't getting this, and yeah, I know nothing about the thing that was just mentioned.
I'm not going to send this until after you make your announcement.
What's that? Oh, okay.
So what are we waiting
I don't know. No idea. They're just trying to get it to work, I guess.
Oh, that's cool.
That's neat.
So
when we do the actual election, I think you would want to also have a check box for write-in votes for nominees.
What would we do that? Use the chat feature for that?
No, he can add the text field to the poll.
yes. But Jeff, you were unable to update your Zoom.
Yeah, but I just saw the link that Eric just posted. I'm going to try that before we get around to all this. But I still think that you can collect votes from your poll, and then if people don't have that, they could just send you the message on the side chat straight to you with their vote.
That would work as well. I'll have to get the report from this so that we can't have people voting more than once.
Kind of like, oh, never mind.
That's a very small population for considering the size of the club, don't you think? We need 10 for a quorum, right? I think that's how it works. So that's at least 10 votes.
I'm gonna look that up. I'm
Pretty sure it's 10.
Oh, you have to have at least 10? Oh, I thought you said a 10th.
No, 10
Yeah.
votes.
Maybe I can check on that.
Hey, Mike, excuse me, before we adjourn, I have a couple of things I'd like to ask the group.
Go for it.
So Eric, I think you probably have the most, the facts about our anniversary.
Yeah, so from our member handbook, there's a nice synopsis of the history of SAS, and it mentions back in 1950 is when the club was first organized. About this time, they first got together to talk about the idea of forming the club informally in September. They held the first board meeting in October, and they had the first general meeting and also the first newsletter in November. So these 3 months here will mark the 70th anniversary.
Happy anniversary, everybody.
Yeah.
Indeed.
And then the other thing I wanted to ask Mike is some of you know myself and Doug and Fred have a small committee working on the January installation dinner. And we're looking into alternatives, and obviously with the social distancing requirements, it's a dilemma, and we've not come up with any options other than a virtual meeting, such as this one, another Zoom meeting. But I did want to ask if anybody had any suggestions to make it special we do have a good speaker. We've got Molly returning to us. Fred, maybe you can announce Molly's program, but we've got a good program. We'll have installation of officers. I'll have everything we normally do kind of in an in-person meeting without the dinner and the social interaction. But if there's anything that y'all have that you'd like to suggest we do or explore, please let us know either now or via email or some way. Let Fred or Doug or I know, please.
Yeah, just a real quick follow-up there, Tim. For those that saw Molly Wakeling's presentation on her trip to the Atacama Desert, it was pretty spectacular, some of the images. She's going to return as our keynote speaker, our speaker for the January installation of officers and annual dinner. But it's actually going to be on the physics that she's studying, neutrinos, and I forget exactly what the title was, but it's going to be a very, very strong scientific. Yeah, Rebecca, I see you smiling there. So it ought to be very interesting. Her presentation was pretty spectacular. I expect nonetheless on this one.
Very good.
Okay, anything else, folks? Okay, Jeff's going to announce the winner of the raffle tonight.
Woohoo.
All righty, Raina Leva, congratulations. You have won a Starbucks card. And
Woohoo! Thank you.
you're welcome. Well, don't thank me, thank Mikey.
Thank you, Mike.
You're welcome.
Okay, if there's nothing else, we'll call the meeting over. And I wish you all good health, and we'll see you guys again soon. I guess we're going to have a vote next month. Also, don't forget, dues are due in October. So those of you that have a little extra cash, it'd be an opportune time to pay up. And I will say that I already paid mine. I hope, Jerry, you did get it, right?
Oh, you bet.
Okay, sounds good.
He's already gone to Vegas with
Yeah. Okay. Well, anyway, good night, everyone.
All right.
Good night.
Good night.
Very good to see you, Rebecca and Joseph.
Good night.
And
Good night.
Congratulations again.
Hi.
Yeah, congratulations to both of you. Okay.
All right, I'm going to cut this.
Okay.
There you go. Ah, there's Charlotte.
Yep.
All right.